All right, so welcome back, and as usual, we can't reiterate enough the importance of taking measurements in physics or in the scientific world, because we know to say almost everything is dealing with numbers. You have to make measurements in order for you to keep data or record of anything, be it scientific experiments or in our daily routines. You're driving, you're doing what you have to keep track of numbers. You want to take measurements of something, you have to measure out something. Even when buying shoes, we have what we call shoe size, which means you have to keep track of certain numbers that you are supposed to be using at specific points or at different points in our daily lives. But what we're supposed to know is that when we are taking these numbers, it's not guaranteed 100% accuracy, or that if the number is 10 and even you, when making a measurement, you are going to get a 10. That is not guaranteed because there is always a degree or a percentage of inaccuracy that takes action. And you're going to find that that's going to cause a fluctuation. It's either that number is going to go higher or it's going to go a bit down due to um, what we call errors. So these guys that are calling errors are the ones that are causing fluctuations, that are giving us the degree of inaccuracies that we are going to encounter every time when making a measurement. So what is an error now, so that we understand this properly? This is just actually going to show us a difference between a measured value and the true value. So when you find that you've taken a measurement and you're seeing that there is a certain difference between the exact number that you're looking for. Let's say you're looking for a number, for example, 10. Then the measurement you've taken is telling you maybe 10.1, or maybe it might be 9.9, like that. That means there is an inaccuracy that has taken place there, or that has taken action there. Hence, you are not finding the exact same reading that you are looking for, but something else due to what we are calling errors. So an error is just going to give us a difference between the value that you are measuring and the true value of something. It might be not necessarily the value that you are expecting, but maybe just the actual length of something. You are measuring length of something, then the that something has actual length. Maybe it's a stick or it's a bed, it's whatever. It has its actual length, but when measuring, you're not going to get the actual length for that thing, but um either something low or something a bit higher due to, or it can change due to what we call errors. But the actual idea, or the whole idea, is that we are not getting the actual true value, but we're getting a surplus, either a deficit or a surplus to a certain measurement. And that is due to these guys that we are calling um, errors. And the other thing is uncertainty. So this is basically English. When you say you are uncertain about something, When you say you are uncertain about something, what does that mean? Uncertainty. Anyone who can give it a try. What does uncertainty really mean? Okay, so let me give this example. You're going to find that when you are making measurements still, um, I've already said, say, errors are going to lead to these uncertainties. You've made an error. An error, remember, it's not really um, a mistake, but it's just giving you a fluctuation due to faults in the system that you are using, and it's not really a mistake. So that is going to lead to what we are calling uncertainties. And when you are uncertain about something, that means you have an idea. You expect something to fall into a certain range, but it is not actually exactly the same. So let's say you are taking measurements, and what happens? You're going to find that you take the first measurement, you find that maybe it's 20.2. You take the second measurement, you find that maybe it's 19.87 or 0.89, 20.21. But you're expecting that number to be in the range of 20. That means you're having a degree of uncertainty. Hence, you're just keeping it in a range. There is a range at which you're expecting your measurement to fall in, and that is giving us what we call uncertainty into simpler terms. So, what are some of the causes of these errors, or what are some of the types of errors? So, we actually have three types of errors, because there is what we call systemic errors. Systemic errors, so this is double R. And we also have what we call random errors, like this. So in high school, I'm sure we already talked about the calculations of errors. Where we talked about absolute error, percentage error, things like that. But today's class, we are only going to I'll only describe these guys or the errors in theory, and I'll focus mostly on calculations when it comes to uncertainty. Okay, so what are systemic errors? So these are errors that are, okay, someone has given an answer. Or no, it's not really an answer. Okay, so systemic errors, when you're talking about systemic errors, these are just consistent errors that are going to result due to the flaws in the equipment of or the system that you're using. Let's say, for example, you are doing an experiment and you are not able to come up with the exact measurement of the time that it's taking for a certain reaction due to maybe some faults in the equipment that you're using to measure your time and such things. So let me just write the definition here. Say these are errors or errors resulting from flaws in the equipment used, in the equipment used, or the method that you've used to come up with that particular measurement. Okay, so when you have errors that are due to these guys, we're going to call those systemic errors because they're arising from the materials, the equipment that you're using. It's the system itself that is giving you that error, or the actual method that you are using in order for you to come up with that's a measurement. So we're going to call that a systemic error. And one of or a certain subtype of a systemic error that we can talk about is what we call a zero error. There is this guy that we call a zero error, where you find that you are, or maybe you've gone to the clinic, and this is very common in Zambian clinics. You go to the clinic, maybe you want to measure your mass, you want to stand on a scale, and you find that instead of a scale reading or the initial reading of the scale reading 0.000 or just zero in short, you find that it is maybe already at 2, or maybe it's at 0.8 or something. So the system, or you, when you're standing there, you're supposed to consider this 0.8 or this 2 as zero, whilst in actual sense the initial reading of the scale is not standing at the actual zero as a number. So that means whenever you find the final reading, you're supposed to take note of this guy that you had in the beginning, which was the initial reading, as it was not standing at zero itself. So if you find the final mass, or your final mass as 48 kilograms, you're supposed to remember that you found the scale, or the scale without anything standing on it was already reading 2 kilograms, which means your your actual mass should be 48 minus 2, because you are removing the zero error that you found on your scale. So this zero error is actually an example of what we call a systemic uh, error, because it is resulting from a fault that is in the equipment that you are using. It's not actually you, but the system itself, or the method that you've used to to come up with that measurement. So it is uh, being termed as a systemic error. So these guys can actually be corrected. The systemic errors, they can be corrected when you calibrate your equipment and such. But what you should know is that systemic errors actually lead to poor accuracy. There's poor accuracy because the the source of the error itself is the system that you are using, and not you, as not entirely controlled by you, but the materials and the method, the method that uh, you are using, and it can be reproduced. Systemic errors can actually be reproduced. And the second type of error that we talked about was what we call random errors. Okay, so if we've defined systemic errors as as faults or flaws that are originating from the system, which is equipment or the methods that are being used, then what do we think random errors can be, or what can random errors be? Anyone with an idea? Okay, so these guys that we are calling random errors, it's also another type of errors, but what are we going to notice is that these are unpredictable variations. If we looked at how we describe systemic errors, you're finding that they are predictable because you know to say, okay, my system has a fault. So if I do this, it is going to lead to this. As a result, you're going to find that systemic errors are always directed in one direction. Maybe if the measurement is 20 and you've identified the systemic error that you're encountering, you're going to find that the measurement will always be less than 20 due to that same systemic error that you are having if it is not corrected. So they're actually always moving in one direction. That's how it is on systemic errors. Whilst when you talk about random errors, these guys are actually unpredictable. Unpredictable, and you're going to find that they the measurements that you're going to get are going to be scattered all over, other than them moving in one direction, like systemic errors. Such that if it's high, then it's always high. If it's low, it's always low. With random errors, it's the opposite. Get going to find that one time you take the measurement, it's low. Sometimes you take the measurement, it's high as compared to the actual value, the actual precision or the actual uncertainty that you're expecting. You're going to find that it's always moving in different directions. Either it's high or it's low, depending on uh, uh, the cause itself, because we are calling this one as unpredictable, like that. Okay, so why are these guys unpredictable? Why do you think these measurements are unpredictable? It's due to actually um, the limitations that are out of your control or external environmental factors. So let me just put it like this. I can just say, okay, let me just say measurement limitations, and the environmental factor. If you've ever done a lab for chemistry, you're going to find that there are certain times when um, you're supposed to measure reaction or reaction time. They tend to say measure the reaction or measure the time it takes for the reaction to complete. And they're going to find that your time is actually going, if you check the time that the different groups or the different students are going to get, some are going to get time which is high, some are going to get time which is low, and it is due to sometimes environmental factors. They're going to find that there's temperature that is affecting the time of reaction, or sometimes you didn't put the correct concentrations of your reactants together, hence you are resulting into these results that are scattered all over the place, and they are always predictable due to environmental factors or measurement limitations, and we are going to call those guys random errors. And these guys, they reduce precision because when you're talking about accuracy and precision, okay, so that moves me to another thing. When you're talking about accuracy and precision, you're going to find that accuracy accuracy is just going to give you how close a measurement is to the to true value. Whilst if we talk about precision, we're talking about how consistent the repeated measurements that you're going to get are, or how close they are to each other, as opposed to how they are related to the true value. So to true value here, whilst here it's to each other. So these random errors, they are going to greatly reduce the the precision of your measurements, because I've said they are not directed into one direction, but you're going to find that one of them is very high, one of them is very low. Hence, they're going to reduce the relation or the relationship of the measurements that you're going to take to each other. Like I had included a picture here. Okay, here, just to explain what accuracy and precision is. So you're going to find that if you see something like this on diagram number 1, you're going to say these are accurate and precise because you're aiming at the bull's eye, and everything is almost close to the bull's eye. And I mean, if all the shots that you've taken are close to the bull's eye. Whilst if you look at these guys, yes, they are close to the bull's eye, but are they close enough to each other? No. So we're going to say they are not precise. If we look at these ones, they are very close to each other, but they are not close to the bull's eye. Hence, we're going to say they are precise, but they are not accurate. Whilst if it's the last diagram, you can see that they are far apart from the bull's eye, and they are also far apart from each other. There's no relationship whatsoever to these guys. So we're going to say this is actually due to random errors. There's something that leads you to shoot your shot there. There's one thing that leads you to shoot your shot there, and there. Hence, having results that are very unprecise. So you are greatly reducing the relationship of the measurements to each other when it comes to what we are calling random errors. Are we together then? These guys can also be avoided by propagating of your instrument as usual. Are we together there? Or there's anyone with a question? Okay, so now that we've talked about the different types of errors, let's now talk about accurate or precision. So I mean uncertainty, not precision, sorry, but uncertainty. So I've already explained to you what uncertainty is. You are having a certain range in which you're expecting your value to fall in, and it is just being affected due to the errors that you're getting. Hence, you're having a range. Just saying, okay, maybe it's supposed to be in 20s, or it's supposed to be close to be to 20, but there is something that is affecting that value to be exactly at 20. So we have different types of uncertainty, of which one of them you can say is absolute uncertainty. Absolute uncertainty. And this absolute uncertainty actually just gives us the actual uncertainty that you get from a certain measurement. Let's say if you want to measure something, maybe a number 2504, then there will be an absolute uncertainty, which is the actual number, which is going to give you that range, the uncertainty that you're or we've been discussing. Maybe let's say it's plus or minus 0, or maybe let's say plus or minus 5, just because this number is too big, plus or minus 5. So we're going to say here the absolute uncertainty here is which one? It's the 5, because it's the one which is giving us the range that we're expecting our true value to be. So it's either the number can be, or the actual reading is falling within which range? 2405 plus 5, 2, or 2504 minus 5. So this is going to give us the range in which our true value is existing in. But the number, the actual number which is giving us the uncertainty that we're expecting is this guy, which is the 5 in this case, and we are calling this guy the absolute uncertainty. Like this. Then there's also what we call fractional uncertainty. Fractional uncertainty. Like that. And this is as simple as you are seeing it. So if we say fractional uncertainty, what does it or what does that mean? That means we are finding, or we are getting the fraction of the uncertainty or the absolute uncertainty that we had to the true reading that we're expecting. For example, I can say this is equal to absolute uncertainty divided by the measured value. That means in this case, well, the way I gave an example of 2504 plus or minus 5, our fractional uncertainty, or also known as relative uncertainty, is going to be equal to what? It is going to be equal to the absolute uncertainty, which we said absolute uncertainty is the actual number, which is 5, divided by the measured value, of which what's the measured value in this case? It is 2504. So this is going to give us our relative or fractional uncertainty. And the last one, but not the least, is what we're calling percentage uncertainty. So percentage uncertainty is just as simple as getting the fractional uncertainty that you are or that you've calculated, and multiplying that guy by 100. So if we say absolute uncertainty, this will be equal to absolute uncertainty over measured value multiply this guy by 100%, and it is going to give you what we call percentage uncertainty. So what happens when you are trying to add numbers or perform operations on numbers that have uncertainty? You're going to find maybe you've been requested to add, subtract, divide, or maybe multiply numbers that are having uncertainties. For example, let me just give an example. Let's say maybe they've told you to say add. I'm almost running out of time and I'm trying to finish. So let me start with addition and subtraction. They've told you to say you should add two different numbers, which is 10 plus or 10.0 plus or minus 0.2, and should add this to 5.0 plus or minus 0.1. How do you add these numbers? So when you are given such calculations, all you're supposed to do when you find the final answer is add these guys. You should also add the absolute uncertainties. So in this case, what am I going to do? I'm going to say 10 plus 5, of which this is going to give me 15. Then this 15 that I'm going to get, I'm also going to do what? To add these guys that I'm getting, that I'm having here. And this is working together on both addition and subtraction on numbers that are having uncertainties. So you're supposed to add the absolute uncertainties that you've been given, of which in this case it's 0.2 and the 0.1 that we have in the bracket. So if we add those two guys, we're going to have what? We're going to have 0.3. That means when we perform an addition of these two guys, the final answer we're going to get is this one. The same applies when you're trying to subtract your uncertainty or your numbers that are having uncertainties. Whilst the case is different when you're talking about multiplication and division. When you're talking about multiplication and division of numbers that are having uncertainties, let's say the same way where we've been given 10 plus or minus 0.2, we should multiply this with 5.0 times, or 5.0 plus or minus plus or minus 0.1. What are we supposed to do? You are going to multiply these guys, or you are going to divide these guys. Then what are you going to do with the absolute uncertainties that you've been given? You're going to add the percentage uncertainties. So which means first you're supposed to start with what? You're supposed to find the fraction uncertainty, which will be this absolute divided by 10, even here 0.1 divided by 5. Then you multiply those guys by 100 to find the percentage uncertainties. Then at the end, when you find or you perform your calculation, let's say you multiply or you divide, what do you do to the absolute uncertainty or to the percentage uncertainties? You are just going to add them. So that's that, guys. That's the end of what I wanted to talk about today. And we'll look at examples when discussing the assignment or when solving the assignment that you were given.